All right, Math 1, solving equations and inequalities. We're taking a look at these literal equations. Literal equations just mean they have a lot more than just one variable, but we treat them just the same, okay? So remember, just like we did in class, we had that road map from the school to Little Caesars, and we decided, turn left, turn right, turn left, and then when we solved it, we just went backwards in the opposite order, okay? Same idea. So we're solving for h here. So to get h by itself, h is being, we need to kind of draw a road map here, h is being multiplied by pi and by 25. So what are we going to do? And because they're both numbers, we can just divide by 25 pi. So divide both sides by 25 pi. Do I know what q divided by 25 pi is? I don't, but that doesn't matter because I'm just solving for h. Alright, so let's take a look now, solving for h on this other one. So now once again, we're timesing by that pi r squared. So if I just divide by pi r squared, we end up with q over pi times r squared, which is ugly, but it gets us h by itself. Alright, looking at number 3. So y equals 7 times m plus 6. So if we need to draw that road map, so I've got m. First we would times by 7, then we would add 6. So we go backwards in reverse order. We subtract 6 first. Now, do I know what y minus 6 is? No. So I just leave out y minus 6 equals 7m. Then we did that one, so now we divide by 7. I divide the whole thing by 7, so y minus 6 over 7 equals m. Not the most simple, but I'm not concerned about that. Okay, then take a look at number 4. It's very similar to number 3, isn't it? Okay, so we treat it the same way, right? What happened to m? First we times by x, then we would add b. So we go reverse and do the inverse operation. Minus b from both sides. Do I know what y minus b is? Nope. So I just rewrite it like that. I do know what b minus b is. That's 0. Then we divide by x. Do I know what x is? No. Can I combine those? No, so I just leave it written like this, and we get m by itself. Okay? Now let's just keep adding that complexity to it. Okay, so number 5. What is happening to z? Because we want z by itself. Okay, and this is kind of for number 6 as well, isn't it? Because you should notice, basically got the same thing going on. The main difference is simply this is w and this is 3. So because of the parentheses, first we would actually add 7 this time on both of these. Then we would times by 3, or in this case times by w. So I'm going to put a 3/w. We're doing it in reverse order, so first we divide by 3 or w. So I divide both sides by 3 or both sides by w. Okay, do I know what a divided by 3 is? I don't, so I just leave it that way. But I did cancel that out. So we have z plus 7. Same with here, canceled out the w, z plus 7. Do I know what a divided by w is? No, but I leave it. Okay, then we subtract 7. Now, I don't subtract 7 from 3. I have to rewrite the whole fraction and subtract the 7 after it. Same with this one. I can't combine any of this, so I just write the minus after. And there's both my answers. Okay, looking at 7, solving for x. So what's happening to x here? Well, first, because it's above the fraction, the 2, we would times by 2. Then once we knew that, we would divide by 5, then subtract 9. We're working in opposite order, so we add 9 to both sides first. So we get 2x over 5 equals 6 plus 9. Now we do know what 6 plus 9 is, don't we? Okay, that would give us 15. So that was nice. Then we're going to times by 5. It's the opposite of dividing by 5. Times both sides by 5, and once again this one simplifies a little better, doesn't it? 15 times 5 would give us 75? Yeah. Okay, then we do the opposite of timesing by 2. We divide by 2. And we get x equals 75 over 2, which would be, what, 32.5 if you went with the decimal. Nope, not 2. 7. 37.5, huh? Yep. Just had to double check it. Okay, so now let's look at 8. Are we doing the same thing? Well, first we times by 2, then divide by 5, then we would subtract the 9y. Doing it in reverse, so we start out by adding 9y to both sides. Now this time, can this become 15y? It can't. So because those terms aren't the same. So we get 6 plus 9y this time. Then we times by 5. Now, on this one, we could write it like this, but we can also simplify that too. I could leave it this way, and then just divide by 2, because times by 5, divide by 2, and end up with this. Okay, but I could also go over here. I could also, because I know that 5 times 6 is 30, and 5 times 9 is 45. So I could simplify it this way. Then if I divide everything by 2, I could get x equals 15 plus 45 divided by 2 would be 22.5y. This would be the same thing as this. Okay? You can do it both ways on that one. Alright, last two problems. So, what's happening to x? Well, the parentheses first, so we'd subtract 2. Then, this fraction, we could say times by 3 over 4, or we could say it separate it. We would times by 3 and divide by 4. Okay? I like thinking of it, piecing it up that way, because I think it'll help us. So we can start out by times and by 4. So if we times everything by 4, we get 3 times x minus 2 equals 48. Then we would divide by 3, because that's the opposite. That would cancel. We'd end up with x minus 2 equals 16. Then we add 2 to both sides. We get x equals 18. Okay? So if we're doing the same on 10, okay, same process, except this time, instead of 2, that becomes 2y. So we add by 2y. But we really treat the rest of it the same way, don't we? So we could times by 4. Timesing and dividing by 4 undoes it. Dividing by 3 undoes those ones. So we get x minus 2y equals 16. Then we add the 2y. This time we can't combine them. So we get x equals 16 plus 2y. Alright, well there we go, guys.